Welcome to the show. My name is Bret. I'm here live every week. So if you're new to this channel, come check us out. I've got a couple of announcements for you, and then we're going to bring in our guest. I'm excited about today's show. We're talking all about infrastructure as code and what that really means and the different options you have there. So check out my website. I got these little things at the top. And this show you can always find at bret.live. And then if you're not aware, we talk a lot about this on this channel, but my Discord server, thank you so much to everyone who's in there. We've got over 4,000 people in there now. So you can go to devops.fan and sign up for our free DevOps Discord server. It's the new cool chat, and we have a lot of fun in there, as well as talking about old 80s tech and other random things like memes. All right, so thank you so much, by the way, to all my patrons. You are the reason this show exists and continues to exist, and that the podcast will eventually re-exist as we get back to podcast editing. But in case you want to get all my updates on my open source, major course updates, Anywhere I'm going to be, writing blog posts, whatever, being on different shows, guest for this show, you can show up at patreon.com/Bret Fisher. You don't have to give me any money. You can basically click the little follow button down there, and you will get maybe once a week a notification, an email, some sort of app notification if you use the Patron app. And it's a low traffic, only what I'm creating or updating kind of stuff. If you want to buy me a coffee every month and support this show and my other open source efforts, always appreciated. Thank you so much to those that are supporting me today. Also, remember, DockerCon's coming up. Spending way too much of my time lately, hoping to make an awesome show for live streaming at DockerCon. We're going to have live stuff going on all day, as well as a bunch of pre-recorded sessions with chat. It's all going to be free. So it's not just about Docker, right? Like Docker is an ecosystem now. So we're going to have tons of stuff about CI/CD, Kubernetes. I'm doing live panels on GitOps and server, what I'm calling admin list server infrastructure, basically never having to use SSH again. How do you do that in containers? I think we've got a modern CI/CD panel that I'm hosting. All sorts of stuff going on there. So, and we haven't got the whole list ready, so more stuff's going to happen. So definitely go there, dockercon.com, whatever, docker.com/dockercon, whatever. You can find it. Just Google it. So that's enough for the rules. Get your questions in early. We're focused on infrastructure tooling today, infrastructure as code specifically, and we're going to talk about Plumi because I'm lucky enough to have as my special guest the CTO of Plumi, Luke Hoban. Thank you so much for being on the show.
Great to be here.
Yeah, we've been planning this for a couple of weeks now, at least, and it seems like in that time the internet knows that you're going to be on my show because I'm seeing YouTube videos from my friends like Victor Farsik over on the DevOps Toolkit channel. Everybody just go check out DevOps Toolkit on YouTube. He does some great content. I was actually late night watching his videos last night on talking about different continuous delivery strategies and what is continuous delivery versus deployment, and whether or not, if you're not automated, are you even continuous? He has a great video, like a 20-minute rant. But let's start, Luke, with what's your background and how did you get started with Plumi?
Yeah, good question. So I mean, for me, I spent a long time actually working on developer tools for application developers in my career. So I worked for a long time at Microsoft. I did mostly sort of programming languages and IDEs and developer tools, but all for kind of application developers, either for kind of Windows or for the web. So had the chance to sort of worked on C#, I worked on F#, I started the TypeScript project, worked on VS Code. And then after spending quite a while at Microsoft, I went over to AWS and worked on EC2 there. So worked on sort of core cloud infrastructure in AWS for a little while. And Plumi was then really this opportunity to kind of bring those two worlds together in a sense. We saw these amazing building blocks that the cloud providers were making available, and especially how those building blocks were becoming so much richer as we kind of moved into the sort of modern cloud era with containers and serverless and things. And yet the tooling that sort of developers and operators had to manage the scale of what they were trying to do with the cloud was still very immature, frankly, relative to what sort of we saw application developers having for managing sort of the scale of complexity of the applications that they were building. And so I think Plumi was sort of born of, hey, can we bring some of that software engineering mindset from the application development world into the sort of infrastructure and cloud infrastructure world, and really rethink what infrastructure as code means and rethink what it means to build cloud software for the modern cloud.
Well, that's quite a background, and I'm a huge fan of a lot of those things you just mentioned. TypeScript, VS Code, absolutely. In fact, it's hard to not go a day and one, use it, and two, like talk about it in the community. It's such a successful project, and it's amazing how for a decade or more we have been various projects like Atom before it. We could have a whole show and you and I could just sit here and riff on VS Code. Right. and we've already done that over the last year. I think we've had like maybe 3 guests where most of our conversation was about VS Code and various the various extensions. It's a great stuff. It's great stuff. So the fact
Yeah, I
that
had the chance to build one of the very first extensions for VS Code, actually. When the sort of extensibility model was about to be made public, when they sort of announced that you could now build extensions publicly, one of the examples they showed off was the Go support, which I had actually built while I was at Microsoft, and now that's sort of one of the tools that folks commonly use for working with Go is the VS Code support for Go. And
so you're like an extension founder. you get
Yeah.
like a special badge or
Yeah.
something. Yeah, that's great. I mean, I think, you know, we could go down this rabbit hole, but if you're out there and you're not trying out Visual Studio Code, if you're not using it for infrastructure, and specifically because those of us in the infrastructure space, like we've spent most of our career probably in, maybe if on the Windows side, maybe you're in Notepad++ or something like that. But on once you started getting into the Linux side and then eventually Mac, we were all in Vim and Emacs because you spent so much of your time on servers. You didn't have a GUI on the server usually. So we all just kind of lived in this Vim world with, you know, sometimes it's Vim hell, at least for me. I'm a Vim, not Emacs person. And we've had all these different editors over the years that they were always focused on code, right? And I felt like VS Code was really the first one, and the extension market, like you're talking about, was what started to become amazing for infrastructure people, for ops people. You know, the YAML support is fantastic. The Docker, the Kubernetes, like all these extensions, Terraform, you name it. And so it'll probably come up later in this conversation when we talk more about your stuff. But
no, I think it is tied into actually Plumi, and you know, one of the benefits of treating infrastructure as code is you get all these ecosystems. You get the IDE ecosystems, you get the tools ecosystems, and you get to bring those to bear on the cloud as well.
Yeah, I think as you just started to talk about it, I was just assuming that we could talk about Plumi in VS Code, because if you came from that background, and you're CTO, you could tell people what to do, and you could say, look, we're going to make some VS Code stuff. But if we're going to talk about VS Code for a minute, like what are some of your favorite extensions that you'd recommend for people, especially in this infrastructure space?
Yeah, I mean, I have dozens of installed. I don't even think anymore about kind of what I use commonly, because I just assume they're all part of the experience. But obviously the Docker extension is fantastic. Has a whole bunch of things. I use that a lot. I recently, one that I'm a big fan of, and I actually saw they just made this the default now, so maybe you don't even have to install it, is Pylance for Python. Is a great sort of extension to make the Python development experience really good. But I believe just last week they actually made that now the default Python experience that comes
really
with VS Code.
So will it recommend it? Will it recommend it when I open up a Python file, and you know how it says, oh, do you need these extensions for this file type? Yeah.
I think what they did was they actually made it just the default. So now, you know, if you have Python IntelliSense and Python completion at all, that's now using this Pylance server. But that one's one that I was really happy when I started using. Other than that, I have a lot of different things installed, but nothing that comes to mind as particularly. Obviously, the Go support I find very important for a lot of our internal development we do with Go, and so now I'm a daily user of that extension.
Golang, yeah. Yeah, we don't get deep into programming languages a whole lot on this show. We tend to cater more into the infrastructure tooling part of it. But there have been numerous great talks at conferences over the last 3 or 4 years about Go becoming your infrastructure language. If you dive into the world of DevOps as a new person, typically one of the most popular questions is, which language should I learn first? If I'm new to development, if I'm coming maybe from an ops side or sysadmin side, or if I'm just new to this whole thing, and they're overwhelmed with all the tools and the choices, and I tend to recommend Bash just because if they don't know that first, like if you don't know the shell really, really well, like other languages aren't going to maybe make up for that lack of Bash. But Python has forever been that default sort of assumption, right? Python. But there's some good arguments recently in these last few years, since you're mentioning Go, about Go possibly being, for infrastructure tooling, the better language, simply because it's easier to package and deploy. Yeah. And for infrastructure people, we really, really care about that. Like, we want easy tools that we can move around and use everywhere and put them in containers without a lot of fuss. So for those of you out there watching, go look up you're on YouTube already. Go after this show, go look up Golang for DevOps or something, or Go for DevOps or something like that. Because yeah, Luke's not wrong. Like there are definitely people out there that are talking about it. So let's before we get to the questions, I see all the questions coming in. Thank you, everyone. Before we get to that, where did the idea so Plumi got started as a concept around, could we make infrastructure automation better, right? Like that's kind of the and when did it start? Because I've only recently learned about it in like the last year or so.
Yeah. So we started the company kind of 4 years ago and launched the open source project that's sort of the heart of what we do, kind of about nearly 3 years ago, I guess now. And so really, from your perspective, in a sense, Plumi's been out there for 3 years, but definitely has been growing quickly in those 3 years. And so I think that means that over the last year, a lot of folks are hearing about it for the first time, in a sense, because just we've grown quite a bit in that time. And yeah, I think the start of the project was really, I kind of mentioned the very abstract notion of, hey, we want to bring software engineering ideas to infrastructure. But I think the one of the core enabling ideas behind that was then, hey, if we use, instead of creating kind of a new DSL or a new sort of, you see the cloud formations, the Terraforms, the variety of other things that are out there that are popular today. If we want to really embrace infrastructure as code and all the things that code can enable for users, we need to actually leverage the same programming languages that are out there that folks are using today. So we started with TypeScript and Python. We added Go. We've now added .NET. In theory, we can support a lot. We can support any language over time, and we'll sort of add more and more languages. But those languages are really a means to give you the ability to have all that sort of software engineering benefits that you get from those programming languages. So that IDE support that we were just talking about, the ability to test your infrastructure, the ability to have linting over your code, to be able to have package management, the ability to, programming languages are really good at reuse, right? I can factor out some code into a function, and then I can reuse that function across multiple places. I can package it up and version it. All these things that are sort of standard parts of sort of application development that are really important for kind of scaling up how a team or an organization builds complex systems. We can bring all that into how you manage complex cloud infrastructure. And I think today, a lot of folks have kind of gone from cloud infrastructure being something where maybe I've got 10 things and they change not that often. Like I've this VM and this VM and this network. Right. Now they've got 10,000 things and they're changing every day. And that level of richness, but also complexity, means that there's new challenges around how to manage that. And I think we view that software engineering ideas can really help with that.
Yeah, once we stopped having to build servers in a data center and we could give everyone the argument of, well, we need 2 months before you can have your thing.
Exactly.
We've got to order it and build it. Once that started going away, and then VMs, it went to weeks. Usually in big data centers, it still took weeks to set up VMs and get everything ready to go and patched and all that. And now it's like this week, possibly today, the new request for the new thing, right? Depending on what, I guess, like organization's maturity model is. One of the questions that I like to ask is, because we're a lot of us in DevOps, especially in the cloud native space, we're a little overwhelmed with tooling, I think. There's so many ideas, like the power of GitHub, the power of VS Code, all these things that have enabled the ability for us to have an idea and then share it with the world and get everyone involved really quickly. CNCF's helping with that, definitely with the community part. So now we have this new problem where the ideas come fast and furious, and it's sort of a joke, like what are the new products this week, right? So coming back to Plumi, like, where do you see this? What do you see this replacing? Because one of the challenges with teams is usually, like, if we're going to add a new tool, can we replace a tool so that we can not have yet another thing that we have to worry about, right? Where do you see this fitting?
Yeah, so I think Plumi ends up sitting obviously in the infrastructure as code space, and so it either displaces some existing infrastructure as code tool, or more often than not, actually becomes the the initial infrastructure as code tool for some project that is either greenfield or that was in an environment where it didn't have an infrastructure as code presence. So someone had, point and clicked in the console, created a bunch of stuff, and now they're at a scale where they're realizing, hey, we need to actually manage this sort of in a reliable way. We need to stand up staging environments. We need the ability to have developer environments. We need to know what's going to change when we want to make some change. And so they want to bring in that sort of infrastructure as code discipline, and they're looking at options and they're saying, hey, like Plumi is actually a better option than the others. But for the things that we see folks kind of coming from, Terraform is obviously a big one. Terraform's grown a ton in the last 5 years or so. We're seeing, a lot of folks have been using Terraform to some scale, and a lot of folks coming to Plumi have kind of used Terraform and are hitting the limits of sort of how, the scale of what they're doing now, is hard to manage there. And so they're looking for things that kind of can go beyond that. And they give them some of the sort of software engineering benefits and tooling benefits and things. But folks coming from CloudFormation and Azure Resource Manager and even just Kubernetes YAML and even growing out of a Docker Compose, for example, and wanting something that gives you that same kind of ability to manage a handful of container-based resources, but do it in a cloud native way.
Right. I'm actually asking the audience. I can just ask them this. I was typing this while you were talking in the chat, and we're like, what? I have a mic. I could probably ask them in voice.
Right.
So for those that are watching right now live, one of the questions that I think we would ask you is, a lot of these tools out there are YAML based. I am a huge fan of YAML simply because I came from the world of Bash, and we were actually talking about this before the show. There was Bash, there was Python, there was maybe some POSIX, not POSIX compatible Bash. You actually had to make sure that you weren't using SH, that you were using the Bash. So we had all these different things, and of course, if you're in the Windows world, you had PowerShell a little bit mixed in there. You had batch files mixed in there. And going to a world of infrastructure as YAML, to me, was an absolute upgrade because I got to at least have one file format, one standard for how I describe things. It didn't mean that it solved all the problems. It created new problems, but I saw that as a improvement. And from what I'm seeing, it's like your idea is, well, let's meet you where you already are. Like if you're a Python, team, if you're a Go team, whatever, we're just going to bring the tool to you so that you don't have to learn necessarily. You probably can't avoid YAML, but you don't necessarily have to conform to a bunch of other people's ideas. They can approach it that way. Do you see? Go ahead. I was going to.
I think it's all a great point. I actually think YAML is fantastic for a certain scale. The challenge we see often is when that scale when the amount of that YAML that you're managing becomes large.
Right.
And you see this sort of in the Kubernetes ecosystem, for example. They have the YAML-based format that is the sort of lingua franca for kind of every tool that interacts with Kubernetes. And yet in practice, you go talk to just about any team using Kubernetes for real, and they're finding that they need tools to sit on top of that YAML. So they need to build templating systems, or they need to use Helm, or they need to use one of the 5 or 6 different systems that now generate the YAML for Kubernetes based on other kinds of YAML that it can sort of have abstractions and the ability to do reuse and that sort of thing. Because otherwise you end up basically just copy pasting giant blocks of YAML around all over the place to do reuse and to do core software engineering things. Becomes very messy, becomes very hard to manage, very hard to understand what you have in production. And so I think YAML is a great core model. I think, for the Kubernetes ecosystem, for example, like great as sort of the core data model in a sense that there's a core representation. But for kind of end users interacting with those systems, I think even when that is the core model, you see people needing to find tools that help them manage complexity. And that tends to be reinventing aspects of programming languages. Sometimes it's in the guise of templating systems, sometimes it's in the other forms, but I think once you get to certain levels of complexity, you kind of need to bring in some of those concepts around how do I how do I create a reusable component? How do I, create for loops so that I don't have to copy paste that thing,
Right.
n times. I can just write a for loop. Just some of this very simple stuff. But yeah, so I think, our in some sense, our view isn't so that YAML is bad per se. In fact, like one of the things we think about all the time, and we probably will do at some point here soon, is actually make YAML available as one of the language choices for Plumi, just so that there is a very simple, kind of sort of data model focused way to interact with the Plumi resource model. But that said, I think, at certain scales, it becomes important to have tools that give you a bit more richness in how you can express things.
Yeah, and I think this is very timely for me because I'm working on a fairly complex project with a customer that it is sort of like you're talking about. One of the types of users is people that are automating for the first time, that maybe the only thing they really had in the past was probably just Jenkins with a whole lot of scripting, and it was running command line tools for you, so you had to know the command line tools and you had to know Jenkins, and you probably didn't understand, you probably didn't even have access to see the status of things or run things yourself because it was owned by the traditional CI team.
Yeah.
And one of the challenges with even with all this new open source CI stuff in the cloud native space is you end up with a bunch of repos and you don't really understand how they all relate to each other. And the logic, sort of the workflow of everything is hidden behind a various set of tools that when you're looking at a program, you can, assuming you're a programmer in that language and that you're involved with that project, you can understand a little bit of the logic and the way that program is meant to run and what it's supposed to be doing, usually in a single repo, right? At least for unless you're doing super microservices kind of thing. But the challenge with a lot of infrastructure stuff is you're going to have your Helm charts over here. I've got some customized stuff in this repo. I've got some Argo CD stuff in this repo. I've got some infrastructure bash that still needs to exist over in this repo. And maybe they're all, some of it's tied together with this Jenkins things we have over here. Some over here is GitHub Actions. And it becomes a real hard problem to say, well, in order to simplify this, we want to stick with one tool. Because one infrastructure tool, like you're saying, that tool may not even have a for each loop. So you're going to end up with complexity there that you're having to wrap around and all that stuff. So how do you see that? How do you see that happening with people that are implementing Plumi? Like, is it getting simpler for them?
I think there's two pieces that are kind of important that lead a lot of folks to adopt Plumi. One is that sort of the software engineering benefits things, and they've had experience hitting those limits and finding themselves copy pasting things, and finding themselves not being able to manage that complexity. But the other is sort of to the point you just mentioned is actually just they've got several different things. So they're working with AWS resources, they're working with Kubernetes resources, they're working with Docker containers, they're working at a few different levels, and maybe they used to have different tools for each one of those things because hey, they've got they've got CloudFormation over here, they've got Kubernetes YAML over here, they've got Docker, and then they had different build pipelines and different deployment systems and lots of bash to stick all those things together. And one of the things that Plumi can sort of do is be a single pane of glass across all of those things, because Plumi supports, all the major cloud providers, a whole long tail of sort of additional things. Plus, Kubernetes is an important platform that we have really great support for. And so a lot of users of Plumi are actually using it for sort of multiple of these at once as a way to simplify that tool matrix in a sense, and have a single tool that can work across sort of the entire life cycle of some service or some application sort of delivery. And I think that is a key way of simplifying as well. To your point, there's always that question when it's N+1 tools. It's like, why would I bring in that extra one?
Right.
And I think one of the biggest reasons why Plumi can often be good there is because it can let you replace several tools and net simplify the sort of tool chain that you've got involved in your deployments.
Yeah, there's lots of, we all have our own like view of the ecosystem, and we all have our biases, and I tend to get involved with teams that are that they're just now doing containers, right? Whether that 3 years ago when I was doing projects, they were just starting to use containers. even in today in 2021, it tends to be teams that are just starting to use containers, or maybe they've done some Docker Lite in the past, but now they're really going all in with Kubernetes in production and whatnot. And I would say that the tool exhaustion is real, especially for dev teams that are getting more involved with this ops world. And I'm always looking for ways to help with that, right? Like that's I think one of the things that I'm constantly trying to improve is like, how do I not wear them out with yet another tool that we need this now. If you're going to do it the cloud native way, you got to do this and this and this, and they just, there's a limit. Everyone's got a limit, and I start to get pushback. Right, you feel that pushback of saying, do we really need this tool yet again? Another one. So when you see people adopting as new automation, like people that are new to automation, maybe let's say they've got a scenario of a Jenkins background, but they've been doing stuff in CI. Maybe their CD is really humans typing commands. Maybe they're using kube control or whatever. How do you see them typically implementing this tool? Is there a way where they typically go trying to solve Kubernetes problems first? Is there a typical workflow where they add it for a particular part of the, because you guys, it seems like, I'm going to ask another question. One of your bragging rights seems to be that whenever a cloud comes out with a new API for something, that you've got it, you're ready for it, right? Before it's even live. I saw that recently on your Twitter. So
no, it is. I think Plumi is very horizontal. And it's one of the interesting things about Plumi is it supports sort of just everything in the cloud. And so that means there's a lot of different use cases that come in with that. And so there's sort of not really one use case that we see. There's hey, someone's going to come and build networking infrastructure on AWS, and someone's going to build, Kubernetes infrastructure on Azure, and someone's going to build some Cloudflare plus DigitalOcean thing, right? And so there's a lot of different use cases there. But the ones that I think are very common for us, a couple. One is managed Kubernetes infrastructure. Is a very common thing for Plumi, and I think that's in part because, well, a lot of folks are obviously moving into Kubernetes. There's a lot of enterprises and folks who are bringing in Kubernetes into their organization in a big way right now, and so a lot of those folks want to use some of these managed Kubernetes services in the cloud, whether it's AKS or EKS or GKE or what have you. And setting those services up, especially in sort of a production-ready way that integrates with the rest of their cloud infrastructure, is not entirely trivial. And so they want to sort of do that with an infrastructure as code tool, and Plumi makes that pretty easy. And then I think the other piece with that is that setting up those managed Kubernetes clusters also involves deploying a bunch of sort of shared services into the cluster to sort of build. With Kubernetes, Kubernetes out of the box is a very basic platform, but why it's so great is that you can bring in all these additional pieces that the ecosystem is built to sort of build out a great platform as a service for your organization. But doing that requires sort of putting all the shared services in place, putting all of the systems in place to deliver workloads into Kubernetes. And so connecting all those pieces, connecting the stuff you have to do in your cloud provider with the stuff you have to do by managing things inside the Kubernetes cluster itself, all of that sort of Plumi can do in a really nice way and package up. And so we see a lot of users coming in with sort of that specific, some version of that specific goal. And then there's a lot that are just doing things like, hey, they're doing much simpler. They've got containers. They're sort of an application development team building container-based workloads, delivering those into sort of ECS, Fargate style things in the cloud. And they just want to build up a simple system to easily deliver their containers that they're developing, and they want to quickly be able to iterate on things and deliver those into the cloud, into whatever cloud environment it is. And for something like ECS or Fargate, they just want some simple infrastructure building blocks to make that easy.
Yeah. Okay, so what's the term, as we're starting to talk about the details of this? Is it extensions? Like when I want to talk to AWS,
yeah,
Is that like an extension? What is that? What do you call that?
We call them providers,
Providers, okay.
but yeah, cloud providers, and we Plumi providers that connect to the cloud. But yeah, one of the interesting things, we have several different ways you can sort of build these providers, and one of the things we did early on was actually create a bridge so that you could take any Terraform resource provider and use it via the Plumi programming model. And that meant that the long tail of open source for Terraform providers that connect to a lot of different things, you could kind of use all of those. And so that gave people a familiar option for mapping cloud resources into Plumi. But over the last year or two, we've been really focused actually on building what we call native providers, which are specific to Plumi. They take full advantage of the Plumi resource model natively, but also are generated directly off of the cloud providers API definitions. And so that means, I think this is so what you may have seen there, that means that we can have day one support for every new feature the cloud provider delivers. So when they deliver a new feature and they push it out into their API specifications, we pick that up and automatically generate new SDKs. And so we have much quicker access. We have 100% coverage of the surface area of the clouds. And we have, I sort of talk about it as, we have fewer bugs in a sense, because there's not an extra layer there, sort of the cloud provider, and then just an automatically generated mapping of that into the Plumi resource model.
Right.
And so that just means you just get this really great ability to do everything that the cloud gives you on day one. And when you see that blog post from Azure that they release some new feature you want to try out, you know that it's going to be there kind of in your Plumi SDK within 24 hours.
Right. That's really great. Because when you've settled on a certain set of infrastructure tools or a way about doing your automation, and then a cloud provider or some other something like that, they come out with something new, and you're excited about that, but your tooling doesn't support it, or maybe they've got their own tool, right? That's a new tool. That's always a challenge, because now it's just another friction point, a barrier for me to even consider that, because a lot of times, if I'm someone who is working with a dev team and they've got a bunch of stuff they need to put in the cloud, a bunch of the apps they've written, there's probably some apps in there that they've got, they might want to, in dev or test, they might want to just run databases or Redis queues or something on their own and not necessarily use cloud provided. So we might be using a combination of containers that we have to build, containers that, or Docker Hub's providing. We're using some cloud resources. So we've automatically, like, if you just at the baseline there, you're now already talking about, like, we've got to have Terraform. By the way, that's just a jet. I have a jet flying overhead. I live near a jet base in the Navy. So I've already, like, the tool list to just implement that gets a little bit, even for someone who's seasoned, right? That gets a little bit intimidating, because now I got to write some Terraform. I've got to write, I've probably got some Docker stuff in there. I've definitely got some kube control, probably some Helm stuff. In order to actually get it deployed, I probably got some Argo stuff. So I've got, 7, 8 command line tools, different YAML formats. Would it be possible in Plumi for me to, like, push all those aside and, like, create the resources directly, and then talk to Kubernetes directly, build my containers directly? Like, how how's that look?
Yeah, no, really, you can do effectively all of that via Plumi. In fact, maybe I'll just swap over if we've got time. I'll do a couple of quick demos here and just show off some of the similar things to what you were talking about there, and then we can come back and take some of the questions. So, maybe just before I dive into an interesting demo that speaks to one of those things, I'll just show the core workflow of using Plumi. And so the key thing with Plumi, of course, is we're starting with existing programming languages. And so I'll do TypeScript here. Obviously, I have a personal affinity there, but everything I'm showing here would work in TypeScript or Python or Go or .NET or any of the other languages that we'll support going forward. But the core thing I can do is sort of say something like, so, the core thing here is we're inside an IDE. So we get, if I type AWS dot, I get, every different, every different namespace that's available inside the AWS provider. And so I can go to S3. And,
hey, Luke, I think you need to share your screen real quick.
Oh, did I not share? Okay.
Yeah, that's okay. I kept waiting for it to show up, and I'm like, I think it's going to show up. I think it's going to show up.
All right.
There we go.
Can you see the screen now? Yeah. There we go.
All right.
Okay. So I'm inside an IDE here. So I'm inside, Visual Studio Code, as we talked about earlier, and I'm using TypeScript. And so, I can just say new AWS dot. And one of the first things is because I'm in sort of an IDE environment, I just get those sort of navigation benefits of now I can go explore and discover what's available. I can see everything that's in AWS. Obviously there's an enormous number of resources and things in AWS. Even just within S3, there's all these resources. And then the fact that because we're in an IDE, we get these tooltips. And so I can type, s3.bucket and I can see examples of, oh, here's how I use this for a few different scenarios. I can get all that help text just in line. And so I can just create a bucket. And then, one of the things we do with Plumi is let you sort of create some exports. So I want to export the name of this bucket. So I'll just say b.id. Then I can come over here and say Plumi up. And Plumi up is how we deploy this. And so Plumi up sort of takes this program, it runs it to figure out what resources you want to deploy into the cloud. And then it makes sure that what you've got deployed in the cloud matches those resources. And so in this case, it'll be just, we want this bucket. And so we'll go ahead and make sure that that bucket is deployed. Plumi up does a preview first. So it says, here's what we're going to do. We're going to create this stack, and then we're going to create a bucket in AWS. So we want to do that. So we say yes. I'll give it a second to deploy.
So this is running from the Plumi cloud, right? Like this isn't actually talking directly from my machine to AWS?
It's actually a great question. No, this is actually running from your machine. So this is using the Plumi open source project and is deploying, all the deployments happening from your machine. This is actually something that we have really focused on to make sure that, because a lot of our users really want to make sure that they own the deployment environment. That's obviously a security boundary that's very important to them. And so you can put Plumi inside your CI/CD system or your other deployment, inside a Kubernetes operator or whatever, however it is you want to do your deployments. You can run Plumi there, but we found that most of our users actually want to control that environment where they do deployments from, whether it's their local machine or whether it's their CI/CD, and that's a trust boundary that they want to manage themselves. We do, though, hold on to the state of what's deployed. And so when now that you've deployed this bucket, we need to know next time that you deploy that you have that bucket deployed. And so, for example, if I come over here and say, const obj,
right, so that state is cloud-based, not necessarily writing locally in a cache or anything.
That's right. Yeah. So you can actually see that the state for how this manages. Folks who have used Terraform or something, they'll sort of know about state that Terraform has. For Terraform, that's by default all stored locally and things. For Plumi, that's by default stored in a cloud backend. And so here it's stored actually. If I go to this link here, you can go into the Plumi console and kind of see the activity on this stack. So you can see all the deployments I've done to this stack, including the one we just did a couple minutes ago there. And we can see the resources that are under management. So we can see this S3 bucket, and I can click on here. And I don't think I have my credentials in right now, but I could deep dive right into the cloud, the Databus console to go look at that. And so this console is all kind of available as part of the free tier of kind of our Plumi service backend. And so anyone can use this kind of for free. And then we have some paid offerings and things for teams and enterprises who want to collaborate together on larger deployments. But yeah, so then if I deploy one of these things, I can I can say I want this bucket to be a bucket above. I want the key to be maybe index.html. And we can actually use the content for this. We can actually use the fact that we're in just a real programming language, so we can read a file off of disk to populate this. So I have an index.html file. And just write some, in this case, I'm writing some Node.js code, but I could write anything I want. And this just gives me a little bit of extra flexibility, right? Instead of me having just to copy paste that content inside this file, I can leave it in index.html and just say, hey, I want to read that in and make that part of my desired state as well.
Right.
And if I now run Plumi up on this, you'll see it won't try to recreate everything. It knows that I already have the bucket deployed and that the only thing it needs to add is this bucket object. And so if I had changed one of the properties, it would know it only has to change that resource. And so we're doing this sort of desired state model where we understand what state do you want to get to, what state are you in, and we're going to make the minimal delta to your cloud provider to accomplish that. And so I can see the details and hit yes, and now I'm going to actually deploy that object into that bucket as well.
All right. Yeah, and because it's I think you mentioned this a while ago when you were talking about bigger teams and enterprises, because the state is in the cloud, which is inherently with a lot of these tools out of the box, this state isn't is local, and that's a
Right.
challenge. The minute you want to add a second person to your team, that's a challenge. So out of the box, the default here you're saying is that the state is cloud based, executed locally, but cloud based state, so that you don't presume there's a single person that only cares about this.
Yeah, that's exactly right, and I think that by default as well. It's by default, but when you kind of download the tool, you have the choice if you want to go and manage that locally. If you don't want to have
Okay.
the state shared with Plumi, you have that choice. But if you just hit enter, you kind of get logged into the service backend, and you get that for free. And so the vast majority of our users do actually use that sort of Plumi service backend. We do have some customers who want to manage that themselves, and that's that's great as well. So,
All right.
yeah, so that's a really super simple example, but to kind of get to some of the things that you were talking about, I'll just show, I won't go through these in depth, but just show sort of some vignettes of some of the kind of things you can do. So one, just a simple container thing is this example of, with Azure, here we create a resource group. And so this could contain all the different resources we've got associated with this deployment. And then in this case, we're just using Azure container instances, which folks may or may not be familiar with. It's Azure's really simple container service that lets you just take a container image and run it directly. You don't have to have Kubernetes. You don't have to have anything else. And so in this case, I just say I want to create a container. The container definition is just sort of the standard thing you'd expect from kind of a Docker environment. So it looks like I've got an extra tab in there. We just provide an image name. In this case, it's something that the Microsoft team provided here. We say what ports we want to expose, and we put in some resource requests. And then we basically just provide some, what ports do we want to expose publicly here. And ultimately, this is all we have to write. And then we can just, this is another example. We just Plumi up this. And after a couple of minutes, we get back an IP address. And that IP address actually, did it work this time? There we go. Yeah, so we've got this IP address. We just deployed this a couple seconds ago. There we go. So now I've got some app deployed, and it looks like it took 2 minutes to deploy that container instance, but we're able to do that with Plumi. Right. And so there we're sort of deploying a container into Azure in this case, and running it as a service inside Azure, but doing that through infrastructure as code and inside an ID here.
Yeah, nice. There's a question that's related to this, I guess. Nicholas was asking, how do you manage other non-developer resources such as VPCs, transit GTWs, Route 53s? So it sounds like these are just objects. These are all just objects in your API.
That's exactly right. Yeah. So I mean, in fact, do I have? So I mean, you could go EC2 transit gateway. So or VPC, all these are just objects. So here you can see some examples of I just write this to create a view to VPC. We even for some of the core networking stuff, we actually have some libraries that we make available that sort of sit on top of the core AWS library. So if you want to create a VPC, for example, a fully functioning VPC is probably 50 or 60 different AWS resources you've got to stitch together to kind of do a best practices VPC with the route tables and the subnets and everything. And so we provide some libraries that make it really easy. You can literally just say, create a VPC with 2 public subnets and 2 private subnets, and it'll go and create all the resources you need for that to kind of do that with the best layout. So
a little more opinionated, maybe. Yeah.
Yeah, exactly. It's not going to fit everyone's needs, but it's going to make it easy if you don't want to go and immerse yourself in all the details of VPC design in AWS. It's a good starting point.
Well, and that kind of speaks to this whole tool as well, because I tend to be a fan of opinionated tooling, because I think if you're an advanced team and you are, everyone's super smart engineers, you have plenty of senior resources on your team, you tend to already know what tools you want and how the team's going to work, and you don't need to have so much handholding. But for a lot of us, young teams, they need that opinionated stuff. Can you still hear me?
Yeah, I can still hear you. Yeah.
Oh, okay. So they need that handholding. So having some easier examples, easier deployments is a good thing, I think, because it can really lower the barrier for a lot of teams that are trying to get started.
Yeah, and I think that's actually one of the things, one of the core reasons why we think that sort of programming languages are so useful is because one of the core things that programming languages do is that you build sort of abstractions and reuse. And that's what sort of leads to, in the application development world, leads to these higher level frameworks, right? Like I get React, and I get, these simple, I get Ruby on Rails, and I get these libraries that help me to build common pieces of software without learning about, network sockets and all these underlying low level pieces. I can work at the level that makes sense for my application. And that's something that in the infrastructure world is often not true, especially in infrastructure as code. When folks think about infrastructure as code, they typically think about dropping right down to the lowest level building blocks and working with VPCs and that sort of thing.
Right.
And one of the things we think about is, hey, how can we bring up level that experience by building these same kind of libraries and same kind of abstractions? And actually, the next example I had here is a perfect example. Well, there's two that I have that are sort of kind of great examples of that. One is a Kubernetes specific example. And so this is sort of the Kubernetes guest book example that sort of has been out on Kubernetes.io since the very days of the project. Everyone's probably seen this before. And so this is it sort of transliterated, transliterating the YAML for this into Plumi just raw. And you can see, Plumi lets you express the entire, the whole Kubernetes API. So exactly everything that's available inside the Kubernetes API is available here within Plumi, and I can just write it effectively in JSON because it's in TypeScript here. But yeah, I get this benefit that, hey, if I mistype something, I get that error. If I have the wrong type for something, like if I think that I can pass numbers instead of these funky strings to the Kubernetes API, I get that warning right away. A handful of these helpful things that you just get from being code. Other than that, this is really just the same as effectively doing it in YAML, right? And so it's no better, it's no worse. It's just kind of the same thing. But if you look at this, there's a ton of boilerplate. You sort of see this, anyone doing Kubernetes sort of feels this pretty much immediately, that you're repeating yourself a lot, right? And you're kind of doing the same patterns a lot. And so one of the things we did was, for this example, was kind of take it and that entire thing, which is sort of, it boils down to 3 deployments and 3 services, right? It's a Redis leader, a Redis replica, and then a PHP front end. And here's that turned into, where we kind of took the implementation of all that sort of duplication and created a new thing called service deployment, right? And the service deployment is a service and a deployment tied together in a natural way. I kind of like the abstraction level that you'd expect from a Docker Compose or something like that. Where I just kind of say image and ports, and everything else is sort of inferred, right? And if I want to say replicas, hey, I can say that. If I want to say that I want to allocate an IP address, hey, I can say that. But now I've taken that whole thing that was, what was that, like quite a lot of code here, right? It's 128 lines of code or something. I've turned that into just a very short thing. I can kind of look at this and just eyeball this and understand exactly what's going on, because I'm working at the right level of abstraction here. And that's all done just, it's not super fancy. It's just this one little, I've created a class and, described how the various pieces stitch together. But now users get to work at this level instead. And I think that's one of the core benefits of using software like this.
Yeah, that's a great example too, because when your first step in going from Docker Compose and having a Docker Compose service with a published port, and then seeing what you have to do in order to do that same exact thing in Kubernetes manifest, that's usually like the first time that people come back and complain. Right, like they're saying, really, do I really have to have 150 or 100 lines or whatever this stuff? It may not be quite 100 lines for the most basic example, but still, I like this concept of this is not a Kubernetes resource. You're not just doing literal translation of TypeScript to Kubernetes resource YAML. This is again another opinionated way of, hey, most deployments, a lot of them. Maybe not most, but a significant portion of them will probably have a service, and most services are probably going to deployments. So let's just combine this into one. Yeah, and there's a lot of other tools obviously out there that are trying to do that.
Definitely, yeah.
But they tend, so far, the things that we talk a lot about on this show, so far those are one-off tools, right? So we don't really we're not really consolidating tooling. Again, we're adding in yet another tool to the tool chain. So this is really great. I like this idea of having this.
And the one last example I wanted to show, just because I think this one is it makes you maybe think very differently about kind of what this can enable, is sort of is sort of an example that's sort of a bit more end to end. And this is one I always think of, like, if you tell someone you want to build this app, which, when a new video is uploaded, I want to run some compute which extracts out an image out of it, a keyframe, and dump that into a bucket as a JPEG. I can kind of describe that to you in a couple of sentences. I can draw this picture on a whiteboard and sort of make it seem like this is going to be a simple thing to build. And yet, if you imagine what you have to do to go actually build this and deploy it into AWS, you probably get pretty scared, right? There's a lot of different pieces you've got to work with and things. And this kind of speaks to that what we talked about before of, hey, you're managing some containers, you've got this application, this task you've got to run, you've got some Lambda stuff, you've got some buckets. There's all these different pieces you want to stitch together. And one of the things we kind of did with Plumi is, try to make that sort of process really easy. And so this is an example where, just with sort of what fits roughly on a page here, you can kind of see, hey, we can create the bucket that we want to sort of use to manage things. Then we can create a Fargate task definition. So Fargate is AWS's sort of managed sort of serverless Kubernetes service, serverless container service. And it lets you just, again, sort of say, I want to take an image, deploy that and this memory reservation, and I want to put that into AWS. And the great thing that kind of Plumi provides here also, which sort of speaks to sort of the Docker aspect, is we can also just build that image directly from something on the local machine. And so in this case, we've got this folder here with a Docker file in it. This could be my whole application. This could be anything I want. In this case, I'm actually saying I want to locally build that with Docker. I want to create a ECR registry in AWS. I want to push that local image to that ECR registry, and I want to take the image that comes from that and use it as the image for this Fargate task definition. And all of that is sort of just in this line of code, effectively. And so we can kind of provide this really simple way to, if I just Plumi up this application, I've actually built that Docker image, pushed it to a private registry, hooked that up to a service, and have that now running inside AWS. And so this is, again, sort of what we can do with creating abstractions. And the last abstraction I'll just note is even more interesting in a sense, which is when I'm working with serverless things, like a bucket has events on it in AWS, right? So I can run some code when some event happens, like when an object is created. In this case, the code I want to run, well, I'm in a programming language, so I can just write the code right in line, right? So I can say that the callback that I want to run is this code here. And the interesting thing about this is this code will not run during deployment. This will actually get put into a Lambda that now runs whenever an object gets put in this bucket. And so I'm actually able to now sort of combine code that runs during my deployment, that's part of my infrastructure, right, with code that's going to run kind of when my application is actually running itself. And so this ability to combine these two things is also kind of really interesting, and lets folks think a little bit differently about the boundaries around their infrastructure as code.
Right, exactly. Yeah, because it starts to become part of the app at some point. Right. Like and I've got way too many questions to fit into this hour for myself, so I'm going to say let's go back to the audience questions, because I'm already sitting here thinking, various things about how does this relate to my GitHub Actions? Like, could I replace some CI with this? Where does this?
Sure.
Yeah, but that's a bunch of rabbit holes. Let's go down some of the great questions here that people have been asking. Some of these have already been answered, but I'm going to just have you reiterate them, I think, just to cover them. Mike's asking, any Terraform migration path or starting over from scratch? What does that look like?
Yeah, we have a whole bunch of tools, both for Terraform and for the kind of ecosystems folks are coming from, for sort of a variety of different interop modes. So either fully migrating from Terraform, we have a TF to Plumi tool, which lets you just take, in fact, you can go to plumi.com/TF to Plumi. And there's a tool you just paste in your Terraform. It gives you back your Plumi code in any of the languages we support. We also have the ability to migrate, kind of state over. But we also, if you don't want to actually do a full migration, you can also import single resources. So if you point and click to deploy a resource or deployed it with any other tool, you can import that into Plumi in a pretty simple way, either with Plumi import or with a few other things. And then we also, a lot of folks have existing infrastructure they deployed with CloudFormation or Terraform or something like that. And for a new project, they want to do that in Plumi, but they still want to be able to kind of reference all the existing pieces. And so we have the ability to what we call stack reference for Plumi to Plumi, but also to reference, you can reference a remote state file in Terraform or a CloudFormation template that's deployed, get its outputs and use those to parameterize how you build Plumi infrastructure. So we recognize that pretty much everyone doing anything real in the cloud today already has some stuff in the cloud and want to interoperate with it or migrate from it or what have you. And so we take very seriously not just building a greenfield solution, but having good solutions to help folks kind of get into Plumi from their existing systems.
Right. It's always that tool to tool migration that's some of the hardest stuff out there. How do I not take my infrastructure down or rebuild brand new infrastructure, but switch a tool?
No, we've had folks move their production environments from being managed with Terraform, big companies, companies that sort of names that have moved production infrastructure over from Terraform to Plumi without impacting any of that existing infrastructure. It's just now Plumi is the thing that's doing the desired state configuration for that.
Right.
So definitely something that we can do.
Nice. Mike has a kind of a similar question he asked earlier about do we have the option to store state in the cloud, our own cloud environment, like with Terraform? You kind of covered that several times. But what does that look like? If I'm, maybe if I'm offline or if I'm in a sort of a lockdown environment where I can't talk to.
Yeah, so we have the option to use the Plumi service as the backend, or then a variety of other things from storing it locally on your machine to Azure Blob Storage or S3 or a variety of other sort of backends. So, and all that's open source as well. So, we can add more backends over time, but generally want to support as many different options as folks have. And a lot of folks do use the S3 and Azure Blob Storage backends. Nice.
Yeah, that's really cool. So we have some comments. TypeScript is here to kill JavaScript. Speak your truth. Let me scroll up and see what else we have. I think we've answered a lot of these. Martin, I think we got to your how Plumi solves the configuration drift problem, maybe? Maybe that's a configuration drift?
Yeah, actually, there's a good question there. So we have a command Plumi refresh, which lets you basically take whatever is currently deployed in your cloud environment and bring it back to Plumi. It's sort of almost the opposite of Plumi up, where it pushes what's in your program out to the cloud. Plumi refresh sort of brings what's ever in your cloud back into that state and lets you know what changes have happened. So there's actually a preview for Plumi refresh as well that says, here, if you do this refresh, here's the deltas that we see between what's really in the cloud and what you thought was in the cloud. And so you can either automate that into your systems, run that nightly or run that hourly or whatever it is to sort of warn yourself if there's drift. We have webhooks in our service. It's not not tied into the open source thing, because obviously webhooks require sort of tying off of a service boundary, but we have webhooks that then you can use to event and let yourself know, so you can fire a Slack message or whatever if there's been some drift there. So we have there's a lot more we want to do there. We've seen a lot of potentially really interesting scenarios for more automation around drift. A few ideas that we've got for the future, but we have the core tools with Plumi refresh and webhooks to help support that.
Yeah, nice. That's a lot of the day two stuff that we don't.
Yeah.
That doesn't always make great demos in traditional tooling, right? Everyone wants to show the day one greenfield magic up, stuff, and the reality is most of us it's way messier than that. And drift detection, people going into UIs and changing things when they shouldn't. Those of us trying to control things with the command line, getting a confliction between that. And that's been a heavy discussion the last few years, especially in the cloud native space, as Kubernetes has become this state engine that we're trying to tie everything to it, use it possibly as a state engine for other things. So this is kind of interesting as a way to do this. Is this something where I'm bullish on GitHub Actions? So I've been talking about it more and more lately. Is this something where I would be performing these commands inside of my GitHub Actions, or is this possibly replacing those actions? I'm trying to figure out.
I think largely you end up putting Plumi into some CI/CD system,
right?
And so you can run it on your local machine, like I was just doing. But in any real world environment where you're managing your production stack or whatever, you're going to want to do that inside some CI/CD. And GitHub Actions is great. We use GitHub Actions ourselves for a ton of the work we do inside Plumi. A lot of our customers are using GitHub Actions in various ways, and so that it works great there. And GitHub Actions also, because it's not really I don't think of it quite as a traditional CI/CD. I think it is more of a sort of workflow model. And so it's really well suited to things like this drift detection piece. Like, hey, I want to run on a regular basis or triggered by some kind of it's triggered by some external webhook kind of thing. I want to run this refresh job, and now I can describe that refresh job as a GitHub action and run that. So we have great integration with GitHub Actions. We have great integration with GitHub, so you can do things like make sure that you get when you open up a PR, you get a preview result like that Plumi preview I showed in the CLI. You get that output in the as a PR comment on your pull request, and that gives you a really easy way to see what's changing and what you're approving and signing off on.
Yeah, that's doing more and more of the things inside of PRs and every commit is definitely, I think, the trend of getting the I'm going to mention Victor Farsick again on his DevOps Toolkit channel. He had a great video recently that, talking about how much of your CI and CD do you trust? Do you trust it so well that I think what he said, if you can bring a random person off the street, show them the list of past CI runs, and allow them to choose any one to deploy into production with a button click. If you don't have that level of trust, then you don't trust your automation, you don't trust your tooling. You still have to have a human validate whether things are going to go well before you do it. And I think a lot of this really comes down to, evaluating on commit, evaluating on pull requests, stuff like that. And it's cool. I like the refreshes. Anything that has a dry run model is like it's going to be a tool in my toolkit eventually if it's got that sort of thing, because we've those of us that are ops side have been dealing with 30 plus years of not having dry run. Like dry run meant have a separate system that I run it on, hoping it's kind of like production and that I can tell whether or not it worked, right? Which is, your test model, your test systems never look like production, doesn't matter how much you try. So the dry run stuff is another layer of that. Doesn't obviously replace all your testing, but I love any tool that builds that in out of the box. Let's see what else we got. I think there was a slightly unrelated a question to our earlier VS Code. I don't see it now, but it was what is your favorite Go extension in VS Code?
Well, it's the main one is now Microsoft's main VS Code main Go extension. Used to be Hoban.go until they kind of renamed it to Microsoft.go.
That's what happens when you get too famous.
That was but no, so that's the one I use.
So it's probably the one.
There's one question I saw here.
Oh, go ahead.
I saw a couple of comments from Liff here, and there was one I actually loved. I loved this use case. He mentioned using the Plumi Automation Api, which is actually a recent thing. We just GA'd that as part of Plumi 3.0, which we just released 3 weeks ago. So pretty. This is the comment here, and. The Plumi Automation API is actually a really fun sort of new thing we've built kind of on top of everything I showed today that lets you then take that, instead of running it via the CLI, actually lets you embed that into your own automation systems. And so, in fact, our Plumi GitHub action is built using the Automation API so that we don't have to just directly invoke the CLI with a bunch of bash scripts. We can sort of control it in an interesting way, and it opens up all these really fascinating scenarios for kind of workflow automation. Some of the things you were talking about, and one is this example that Lyft mentions. If they sounds like they built a tool which, when someone opens a ticket, it creates some infrastructure, and then when they close the ticket, it tears down the infrastructure. And so this sort of idea that you can have your own kind of workflows around how infrastructure life cycles are managed. You can still have that desired state, model, so it's reliable, like when the resources are there and aren't, and that they can be updated. But being able to fully automate those sort of things is really cool. I love that example of kind of using Jira tickets as a way to create and destroy infrastructure.
This is an interesting question from Arpit. Talking about GitOps, because that's a topic on this channel that we've talked about a lot for the last year, is making Git and Git logs sort of the source of truth, the source of state. Being able to do a Git log history and understanding what has changed in my infrastructure. I'm a fan of that. Where does this thing have the capability to sort of write back to, because it sounds like there's definitely some state stuff going on there, and how do you think that kind of fits with that model of the state being represented in Git rather than in another system?
Yeah, I think the key thing is that the program lives in Git, and obviously it's very natural for code to live in Git, and for the TypeScript I was just writing, or the Go or whatever, and that's the really key thing, because that's your desired state, and that's describing what do I want my infrastructure to be. And now you can do really interesting things, and we do this ourselves. We see a lot of folks do interesting patterns, but hey, when I want to promote from one environment to another, I can just merge this commit into my production branch, and now I've got my CI tied so that I'm just going to deploy whatever the desired state, whatever the Plumi code is that's in that commit that merged into that branch. I'm going to trigger a deployment job for that, and so now my Git history does exactly describe what state was my infrastructure in at each step. And then the state itself, is being stored. Say what is actually in the cloud is obviously being stored in the cloud provider itself, but is also being stored in kind of that back end. And so you can then go into the Plumi console and see sort of the parallel version of that, and you can actually link back to each of those Git commits and go and see, hey, go back into GitHub and see, hey, it was this commit that led to this deployment happening. And so we have that cross linking in both directions. But I think it generally does fit really well with general notions of how do I do Git-based deployment workflows.
Right. Yeah, I think the model, I think that like the typical one that I will see people hit first is the problem of, regardless of what tool they're using, right? If they're trying to do Git-based operations management and GitOps kind of stuff, is they turn on some auto scaling, both an amazing feature and also a problem for anything GitOps based. And so then, I get a new replica of my deployment pod in Kubernetes, and now my, whether I had Helm or whatever I was using before, now the replicas of 3 are technically 4, but my Git repo still says 3. Is Plumi kind of fitting into that model there, where it can write back? I know some of the newer tools we're seeing will actually write back to the repo, because you mentioned this refresh. I'm not sure if that refresh is meant to actually be able to write back and basically let the robots take over your Git repo. Is it do that? I mean, is that something that you're...
Yeah, we don't do anything with writing back to your repo. I tend to think that kind of thing is a little bit at scale. It's going to be a little bit hard to manage well. I think our goal is to sort of separate, in a sense, the desired state of the infrastructure from then there's operational pieces, like there's things that you're going to change and aren't part of that desired state, right? That are going to be sort of operator controlled, or are going to be for auto scaling or something. They're going to be fully automated, not even operator controlled. They're just going to be load based or whatever. And so the ideal there is that you sort of describe what you want the desired state to be. You describe if there is a like number of replicas thing, you can in Plumi say ignore changes on that property, which means means you're basically saying that the program, after the initial deployment, the program no longer sort of owns that value, right? It won't try and change it back,
right?
And so it'll let that value drift as much as it needs to. But you can also typically do things with a lot of auto scaling systems. It's not that you want the desired number of replicas to be your desired state. You want some auto scaling conditions, like target 50% load on CPU or something like that. And now that is a desired state that's always going to apply. And now I'm just relying on the robots to go take care of scaling up and scaling down as needed, right?
Yeah, that's true. I do like that approach more than because especially if, depending on your workloads, you could have scaling events up or down a lot, and that in cases where I've seen writebacks, that sort of almost pollutes your history a little bit, because you're now things that you considered innocuous, like, okay, so what, you scaled up two pods, that's within my realms, that's and you scaled back down, and when we're all done, and you, assuming you've thoroughly tested all that, that's a sort of a non-event, do you really want that polluting your infrastructure changes? And so I like that, ignoring these values after, or not, whatever you called it, not owning them after their initial state. I like that approach. That sounds like a good solution there. Did you see anything else in there in the comments?
Yeah, there's a handful of good things in here. There's a question about well, how much Perl do you see being used in DevOps? I like that. No, obviously, lots of Perl. We actually have not gotten many requests for Perl for Plumi. We have gotten a lot of requests for PowerShell, for Ruby, for Rust. Interestingly, that one's a little bit more surprising. It's obvious that I think there's a lot of excitement around Rust generally right now.
Yeah.
I'm not sure it's a perfect fit for infrastructure as code, but we're going to be looking at a lot of different languages as well.
That's true. I mean, I have seen a couple of Rust teams, and not a ton that I've had direct experience with, but they're usually using Rust in combination with another language for higher level stuff that doesn't need as much performance focus as Rust. But yeah, it's a language where everyone's looking at it, I think, right now. It's funny you mentioned the Perl question was not wrong, by the way. Pritish, that is an acceptable question. My answer is I have not seen Perl in the years since I've started calling it DevOps, so like 8 years. I've not seen Perl once. Doesn't mean people aren't using it. Doesn't mean it's a bad language. I don't see it in my world. But we all have biases. And how does this compare with AWS CDK or CDK Terraform? Good question, Samuel.
Yeah, so that's a great question. So CDK is probably the closest thing to Plumi out there today. It also takes the same idea of kind of using existing programming languages. They also interestingly lead with sort of TypeScript. That was their first language they supported. But yeah, so in the model there with AWS CDK in particular, I think that's really tied to AWS, and it really is a tool that transforms from a programming language and generates a CloudFormation template effectively. And so that has some benefits when you kind of want to use existing CloudFormation based tooling, but also constrains what you can do a fair bit in terms of sort of the flexibility. A lot of the examples I showed where you're kind of working across multiple different cloud providers are a bit harder to do there. CDKTF, I think, is the similar idea, but compiling down to Terraform files. And so now you get Terraform, .tf files out, and now you can use your existing Terraform to do that. So as I sort of think of them as templating tools over top of some of these existing ways of writing things. I think Plumi feels similar in some ways in that you're ultimately writing code with these existing programming languages. The biggest difference is just that there isn't this intermediate layer of getting Terraform code or CloudFormation templates, whatever, that you also have to manage. It's deploying it directly and managing it, and that because of that, it can work across multiple cloud providers at once and offer a bit more richness.
Right. It's kind of my. There was a question early on, I think even before we started, about CloudFormation or Terraform, and I get that question a lot on this show actually with this in the students with my courses, and. I think everyone, for that question, well, since we're on the topic, like CloudFormation is something that you probably need to be able to read, but I don't see anyone really writing it. I think maybe like 5-6 years ago, before Terraform really took off, I was still doing, CloudFormation, back before it even supported YAML. We had to do JSON, I think. But I don't see people writing that directly anymore because we have all these other higher level tools. So it's one of those things kind of, there's probably another analogy I can use where it's good to know how to read it, understand what it is, but you don't expect yourself to be committing that to Git repos and writing that stuff directly. It's rare that anyone's AWS only, and even if they are, they're using something else to control AWS for them. But AWS is always going to have their tools. They're always going to have all their own tools for those that want that. I almost feel like you're lucky if you can only have to deal with AWS assets and everything is
absolutely
AWS. You might be one of the luckiest teams ever because the rest of us still have to deal with all the things, not just AWS things.
I would say I've been surprised the amount of. Obviously there's a lot of Terraform out there and things, but the amount of CloudFormation and Azure Resource Manager. There is a lot of organizations that have built up a lot of assets around those and are still working actively, primarily in CloudFormation or primarily in Azure Resource Manager. So we see folks coming from really all three of those: CloudFormation, Azure Resource Manager, Terraform. Those are all significant sources of folks coming into Plumi.
All right, I'm going to do some rapid fire here real quick because we've been going extra long today, getting a lot of good questions in. All right, so. for Kumar, the question around, I'm going to change this question up a little bit. For infrastructure as code, if you have teams that are coming in to Plumi and they're relatively new to automation and IAC, do you give them resources? Do you have stuff to help them with that initial learning? What do you recommend?
Yeah, I mean, I think there's good content out there generally on infrastructure code. We have some good content on our site on Plumi.com. If you search on Plumi.com for infrastructure code, there's some generic learning material there. But then really, Plumi is a core infrastructure code tool. So kind of going through the getting started for Plumi will sort of guide you through a lot of those core concepts of infrastructure as code, just as part of getting up and running with Plumi. And so I think you'll get a very good feel for what it means to manage your infrastructure using code. Just going through, plumi.com/get started.
All right. /get started.
So,
right.
Yeah.
Yeah, perfect. Mike, I'm going to skip your question. Sorry, we're running out of time. Graph command. You have a graph command similar to Terraform to generate visual representation.
We have a couple of things. There is a CLI command that generates dot files, which can be used to render graphs. But then we also have, as part of that Plumi service, that app.plumi.com that I showed briefly, you can go in there and get a graph of all of your resources and their relationship to one another. So yeah.
Okay. Was that the URLs I was seeing when you were typing commands and it was popping up URLs to app.something?
Yeah.
It's kind of
exactly.
like the job.
And if you click on any of those, it'll go in and show you all the details of that deployment and all the resources under management as part of that stack. So yeah.
All right. Nimsha wants us to rate infrastructure as code tools. I'm not sure we have enough time to go through all that, but
I know, yeah.
I'm pretty sure I know how Luke's going to rate it. So
Right.
he's been working hard for years to make his the best. So I'd say that's a good chance there. Does Golang play some role in DevOps? If yes, in what context? Actually, we just started talking about that earlier. Just that it is increasingly becoming, I think, a DevOps language. Mostly, if you look at the cloud native ecosystem, in case you haven't been around and you're not like me, I'm a pretend developer. I spend my days in ops. So people rarely pay me full time to do code. So if you haven't realized, almost every tool in this space of cloud native stuff and distributed computing is all Golang. In fact, it's gotten to the point now where it's actually weird or almost, I hate to say that anyone's looked down upon or whatever. Like, I don't think it's that level, but when a tool comes out that's like, hey, we're an IAC tool, or we're an automation tool, or we're a cloud native tool, and we're in Ruby, like that actually doesn't happen very often. It's almost weird at this point. Not that I don't know exactly what it is, but I know that originally, back in the day, like Docker was originally in Python, actually, or maybe in Bash, actually. No, I think it was Kubernetes that was originally Bash. Docker was originally Python, and I think they kind of I could be getting that wrong, but they all moved to Golang many, many years ago. And so that whole community just kept adding things as Golang to where the point is it's almost a default. I don't know how much of a opinion you have, Luke, on that, but
no, I think it's true that the sort of cloud native ecosystem is very, very Go based from a sort of software implementation perspective. And I think there's some good reasons for that around being able to build single binaries and deploy those easily. And just the tool chain is very simple and has good support for a lot of the core things you need to build that kind of stuff. But from a DevOps perspective, I mean, so I think that describes sort of the software piece, and so a lot of software is being built with Go in that ecosystem. From the kind of DevOps perspective, I think the thing that's interesting for Plumi is Plumi actually lets you now write your infrastructure using Go, right? And so if you do want to use Go and you do want to sort of combine kind of, especially with this automation API I mentioned, there becomes lots of interesting use cases where you're actually building sort of richer automation systems, which maybe do need to be software and do need to be want to be written in Go. But then you want to have those manage infrastructure. And so you want to actually put the infrastructure as well in there. And so we see that pattern. Go has been, it was our most recent language to GA.
Okay.
But it's been one of our fastest growing languages over the last year. So
nice. Yeah. Not a lot. I mean, not a lot of people getting into DevOps are necessarily Go developers. I think people
Yeah.
tend to stumble into Go, as they're getting into the more modern computing, and I see that a lot with my consulting clients as well. They're on other languages, Ruby, Python, Node, whatever, and they start to discover Node as they discover cloud native computing, and they pick it up, and it sort of is infectious a little bit. They start using
Yeah.
it for one-off tools, and then eventually it's starting to write. It's written everywhere. All right, we're gonna get two more questions here. Paul's in here. Paul, I don't think we've given you any. Let's see. Is that actually a question? Are we 100% on AWS and write CloudFormation in JSON manually, although we're using CDK for new projects? Oh, okay. Not a question, but Paul's a regular in here, so I thought I'd highlight whatever he was saying.
Yeah, I think that pattern of doing a lot of AWS and doing it with JSON, with CloudFormation JSON, like that's very, I feel like that story Paul's telling there is something I hear a lot. So
yeah,
we just got to convince Paul to check out Plumi as well. So
right, and I'm going to leave this one as the last one, other than Golang rocks and great for multi-platform, which are all true of Golang. This question is, I'm not going to read the question directly, but I think it speaks to something around, we call this infrastructure as code. In a lot of ways, we're really referring to, it's almost like infrastructure as documented in Git is more maybe, because YAML, a lot of us wouldn't call YAML code.
Yeah. I often joke and talk about it as though, infrastructure as code was really infrastructure as text. What we accomplished with infrastructure code, we found a way to describe our infrastructure using text, and that meant once it was text, now we could put it in Git and we could version control it, and that was great. But when I think about code, I think about all the other things you get. I think about the ability to build reusable components, to build abstractions, to have for loops, to have classes, to have packages, to have versioning, to have testing. Like code for me means all this other stuff, and I think like we really have only barely scratched the surface of bringing what code can really mean for infrastructure to infrastructure as code. I think you're exactly right. To date, it's largely been infrastructure as text.
I like the IAT. I'm not sure if that's an acronym on the internet, but I like your way of describing it better. Yeah, because when we started IAT, I'm going to just keep saying it until it becomes a thing. Git may not even have been the standard, right? So we were all still on Subversion and Team Foundation Server and all these different things. And at least now, like some of these lower level components, like the container image, that I'm a huge fan of, obviously on this show. Some of these core things we can all start to agree on, so that we can work at these higher levels of abstraction and talk about things like Plumi. So I think it's all great stuff. And for those of you that we didn't get to your questions, I'm so sorry. We had a great list of questions today. I really appreciate all of it. I do want to thank Luke so much for being here. You can always tell we're at almost an hour and a half into the show, and we're at peak concurrency on the show, which almost never happens. So obviously the interest is keeping people around and talking about this idea of choosing their favorite language and writing their infrastructure and describing it in their favorite language seems to be a really popular topic. So we're going to have to keep coming back to it as you all extend and what's the next thing? Give me a hot take on what do you?
Yeah,
what do you
we got
about?
a lot. I mean, we just launched Plumi 3.0, and so right now we're sort of heads down, just continuing to make some of the things that were new with Plumi 3.0 even better. We have that automation API we just talked about. We're doing a lot of work to sort of extend that and make that even better. We talked earlier about kind of native providers, building our own providers for each of these major cloud providers. We just GA'd our Azure support. We launched a preview of our GCP support. We are working on AWS support that will be available later this year. And then lots of new higher level libraries. We sort of, as part of Plumi 3.0, also released the ability to sort of create packages and reusable components in one language and make them available to users in any Plumi language. And this is really sort of unlocking having a single Plumi ecosystem of components instead of sort of multiple in each of the different language ecosystems. And so we've just sort of delivered that core platform for doing that. We're now starting to work on really building out a lot of the pieces ourselves and sort of seeding that community and starting to help build out sort of the community of packages and reusable components for infrastructure on top of that.
Right. Well, I forgot to mention that earlier. Congrats on the 3.0 release. I think, what is it they say, like the 2.0, like the 3.0 is the hardest, or maybe it's something like that. Like, because the 1.0 was like, this is our idea. The 2.0 is every feature we could possibly imagine was labeled 2.0, and then it didn't happen. So 3.0 is like the real first release of a product. I think sometimes that's the joke. I don't know if that's still true nowadays, but going back.
No, it feels there is a certain arc that these things have. I remember being part of C# 2.0, 3.0, and 4.0, and like kind of a similar feel of the transitions through those things.
Now that 3.0's out, you have finally done it. Like,
yes,
the wish. I'm sure the wish list is still a mile long, but well, I'm certainly excited to check this out and try it in a project. I noticed by the way, you also have a Slack, so I'm just gonna do that marketing for you and say, hey, if you want to get into the communities, they have a Slack on their website, a Slack team.
Yeah, definitely. I saw Liv's question there. If you go to the website, you click on the Slack link up at the top. There's a Plumi community Slack. There's a ton of folks in there, active discussions all the time about using Plumi, and a lot of the team from Plumi is there as well. So
nice, great. All right, well, I think we're gonna call it a day. An hour and a half, breaking the records. Thank you so much, Luke, for being here. I appreciate your time, and for all of you. We'll be back next week. So remember DockerCon later this month. We'll be back here. We'll be back live next week, like usual. Last week was an exception. I was not live last week. We were actually driving back from seeing my family. Yay, COVID vaccinations. So see us back here next week, and we'll see Luke's on. You can see, by the way, Luke's Twitter handle over there. You can check us both out on Twitter and say hi. We'll see you later on the internet. Bye, everybody.
Thanks all.